Hello again. This lecture is about roll control, ailerons and roll spoilers. This is in your textbook starting on page 86 through 88. Um, the first thing I'm going to show you though is the convention used by Roskam in a different textbook. So this convention is Roskam, different than what's in our textbook. But I wanted to start with this because this is the standard United States USA convention. The way this works is positive aileron on the right wing is trailing edge up. So this trailing edge of this aileron is up, which means you get less lift because the camber is reduced. And because the lift is less, you tend to get less drag on this side. And then the left wing is trailing edge down, changes the camber more positive, so you get more lift and more drag. And so the net effect is you got more lift on this side, less lift on this side, and so you get a net positive rolling moment from positive ailerons. So that gives you the roll. The side effect is the drag, and we're going to talk about that in a minute. So you get less drag on this side and more drag on this side, so you get a net negative yawing moment like this. So you roll positive, yaw negative with the Roskam aileron positive aileron convention. So the lift difference I was just talking about produces a positive roll, and the drag difference between the two wings produces a negative yaw. All right, so let's dig into that a little deeper. Um, that is the Roskam USA convention. So on the next slide here, next sheet, I'm going to show you both conventions. Our textbook does it exactly the opposite. This is the Oetken Convention. Don't know if it's British, but we'll just call it that because they drive on a different side of the road than we do in the U.S. So here, this is what's shown on page 87 in your textbook. Positive aileron produces a negative rolling moment and a positive yaw. So that means it will bank to the left and yaw to the right. So the derivatives CL delta A is negative and CN delta R is positive. And of course, these are flipped if we're using the Roskam convention, which is down here. So Roskam has positive aileron, as shown before, producing positive roll, which is right wing down, and negative yaw, which is nose left. Look at that, I can write with the mouse. This is difficult. So this is nose left. So the derivatives CL delta A and CN delta A are corresponding to those sign conventions. Now, the important thing to realize, and now we're going to go back to the Roskam convention, because that's what we tend to use. Here, a positive aileron produces a positive roll, so that rolls banks you to the right. And so when you bank to the right, you tend to turn. Usually you bank the airplane and you start, you turn or bank to the right. But as we said before, that gives us a negative yaw, which is, if you think about it, a negative yaw is kind of yawing out of the turn. You're banking right, you're going to turn right, but then you're yawing the opposite way of the turn. And so pilots don't like that. It feels strange. And it's called adverse yaw because it's in the opposite direction of the turn that you're trying to do when you bank the airplane. So your adverse yaw, you're yawing out of the turn. So that's an unintended side effect of the deflection of the ailerons on the airplane. The intended effect is the roll or the bank, but then you yaw out of the turn. So one way to deal with that is to add something called lift spoilers to the airplane. One of my favorite places, as I said, to sit on an airplane is to sit over the wings so that you can watch the flaps deploy and the ailerons. And if you sit on a commercial jet, you'll also see when it's doing more large commanded bank rolls, you're going to see a flap that's deployed on top of the wing. You'll also see these when it lands because they deploy up and create a bunch of drag to slow the airplane down. But a lift spoiler, if you want to roll right with the positive Roskam convention, then this is deployed here, which means you get less lift on this side and more drag. So the less lift is going to roll you this way because the lift is spoiled on the right wing but not on the left wing. So this is deflected here. You get separated flow behind the lift spoiler, so that kills the lift because the flow is separated, and you get more drag from that separated flow, which means you get the positive roll, but because the drag is higher on this side than it is on this side because of that separated flow, you also get a positive yaw. I guess you could call it proverse, but it just means it's yaw into the turn as well as banking into the turn. So that's the benefit of using a lift spoiler. And this is the description: less lift on the right wing, more drag on the right wing, and so you get positive roll and positive yaw. So you roll to turn and you also yaw into the turn. So that's a good thing. All right, another aspect about ailerons is that they are called rate control, which means if you keep the aileron deflected, a positive aileron, you get a roll rate, not a deflection. You don't, if you deflect the ailerons, you don't get a deflection to create a bank angle, you get a rate. So if you hold the aileron in, you'll continue to roll and roll and roll. Whereas elevator and rudder are called displacement. Oh, that's a lousy thing. Displacement controls, because pretty much an elevator changes the trim angle of attack and the pitch angle, but it doesn't produce a huge amount of rate. What you do is if you change the elevator, you get a new alpha and a new theta. And a rudder will cause you to side slip to a constant side slip angle. So a little bit of rudder has to be held in to maintain beta, a little bit of elevator to maintain an alpha. Whereas with the ailerons, aileron deflection produces a roll rate. So the way you do that is deflect the ailerons, you roll to get to a new bank angle, and then aileron pretty much goes back to 0 to hold that bank angle. Last thing I want to talk about is aileron reversal. So I'm going to scroll down to look at this picture. What happens is with the positive Roskam convention here, trailing edge up over here, trailing edge down here, you're going to get what you want is a positive roll. That's the aileron deflections, but if the wings are really flexible, this up trailing edge will cause the wingtip to twist down, which means you get actually a higher angle of attack, so you may get more lift on this side when you really want less. Same thing happens over here, trailing edge down, this will twist this wingtip up, giving less angle of attack, and so you'll actually get less lift over here when you wanted more lift from the aileron. So that's called aileron reversal because you get the opposite effect and the airplane actually banks in a different direction than you wanted it to. Deflect this up, this down, you want it to go this way, and you end up actually rolling this way because the wing tip's twisting. You have to design the structure so it's stiff enough so that this does not happen, because this makes the airplane impossible to control. Alright, so that's the end of the lecture about ailerons, positive conventions, both Roskam and Etkin, and what a roll spoiler does, and what can happen if you design your structure too flexible.